Assalamualaikum warahmatullahi wabarakatuh. So today we want to present our group project which is Green Theorem. Before we start, I will introduce our group member. First me, Nurfati Alia binti Abdul Rauf. Second, Yuzrina Izzati binti Zamri.
Okay, let's start with introduction. Green's theorem is one of the four basic theorems of calculus, closely related to Stokes' theorem. It defines the relationship between a curve microscopic calculation and the total of its microscopic calculation. George Green, a British mathematical physicist from the 18th century, is credited with developing this theorem in his 1828 essay. Green was the first to develop a mathematical theory of electricity and magnetism. His work served as the basis for the research of William Thomson, James Clerk Maxwell, and other scientists. Green's research has conducted in tandem with Karl F. Gauss. These contributions are essential for understanding theories of electricity and magnetism as well as fluid flow analysis. For our first case study, a researcher conducted a study on a 65-year-old man who has been diagnosed with a brain tumor. As a researcher who has just received a series of magnetic resonance imaging MRI scans of the patient's brain from a doctor, the brain has a tumor cells in figure 1. What size is the tumor? What is the area of the gray region precisely? To calculate the area of the gray region encircled by the ellipse, apply Green's theorem. Here is the solution for question 1. An equation of the ellipse is x squared over 3 squared plus y squared over 4 squared equal to 1. We start by expressing the ellipse in its parametric form. X and y are given in terms of theta. This will help us set up the integral for Green's theorem. By Green's theorem, a sub r equals to the line integral around c of x dy. This equation stated that area is found by evaluation the line integral of x dy around the curve c. Green's theorem relates a double integral over a region to a line integral over its boundary. Here we use it to convert the area calculation into a line integral. Next, we substitute the parametric into the integral. We substitute x equal to 3 cos theta and dy equal to 4 cos theta t theta into the line integral. This simplifies the integral to 12 from 0 to 2 pi cos squared theta t theta. Next, we simplify the integral by use trigonometry identify cos squared theta equal to 1 plus cos squared theta over 2 to simplify the integral. Next, we evaluate the integral by continue simplify separate the integral into two parts and integrate each term equals 6 times the quantity theta plus sine 2 theta over 2. Evaluate from 0 to 2 pi. For the final calculation, we evaluate the result. After evaluating the integral from 0 to 2 pi, we get 6 multiplied by 2 pi. Therefore, the area is 12 pi. Next, we will go through the process of calculating the area of the gray region enclosed by the ellipse given by the equations x squared over 3 squared plus y squared over 4 squared equal to 1 using method. That final calculated area of the ellipse is 20 pi, confirming our result.
Okay, for question 2, Irene sell cakes. She got the order from two customers and the customer request to do cash on delivery to their house. The distance between Irene's house and the first house is 5 kilometers opposite, while the second customer house is 5 kilometers to the left. Verify Green's theorem for 3x plus y power of 2 dx plus 2y power of 2 and x dy, where c is shown below by. For solution question number 2, using Green's theorem to compute the line integral. So first we must find gradient. So we got 1. The answer is 1, and we must from the equation P is 3x plus y power of 2 and Q is 2y power of 2 plus x. So for P we must differentiate y, so we got 2y, and Q we differentiate x, so get 1. So after we got the answer, we must substitute in formula Green's theorem. So double integrate qx plus py dA. So double integrate 1 minus 2y dA. So we got first integration, we put negative 5 and 0. Another one, 0x plus 5, 1 minus 2y dy dx. So we find dy first. So we got y minus 2y power of 2 divided by 2 and 0x plus 5. So we got y minus y power of 2, 0x plus 5. So we must put 0 in and x plus 5 at the equation, minus them, and we got negative x power of 2 minus 9x minus 20. So another different integrate, negative 5 0 x minus x power of 2 minus 9x minus 20 dx. So we got negative x power of 3 divide 3 minus 9x power of 2 divide 2 minus 20x and negative 5 0. So we must substitute negative 5 and 0 at in the question and minus them. The final answer we got is negative 175 divided by 6. Okay, next, this is a result mapper comment for question number 2. That's all from us. Thank you.